Alright, so let's program some simple controls for a Powerflex 525. And we're going to actually start this with the ControlLogix version. This is going to be 35. So what I have this currently set at right now is 35. So just keep that in mind. I try to stay on the cutting edge and do things the way. So if you see problems, you can address problems, you can answer problems and stuff of that nature. Again, when it comes down to it, I did hold a class on this, and the two guys that were in that class tend to really receive a lot of information from it. They really recommended that I make some more videos on this. So that's what we're doing here. So first, I like to change my task from a continuous to a periodic, just because I believe in proper timing of any kind of PLC. So keep in mind there is no programming done whatsoever in this program right now. We're going to set up our actual Ethernet card. So we're going to come over here. You can only do discover if you're online. So just keep that in mind. So currently, if I look, my Ethernet card that I'm traveling through is a 1756 EN2TD and then firmware 11. Now I need to know that, and then it's actually communicating through slot, or its IP address is 192.168.130. So let's go ahead and add that. Let's go ahead and add in the 1756.en2t, and if my fingers were typed correctly, then we would be in good shape. All right, so we correct this or create this. So creating it right now. We're going to then put our information into the we're going to give it our name. We'll just call this Ethernet module, and we'll give it an IP address and 192.168.130 because that is what it said. Firmware revision, again, we were at 11.2. 11.1 is perfectly fine. We are in slot actually slot 2, so we'll pick that and we'll click OK. And from the next port, we need to come down to our Ethernet, and that's when we're going to select our drive. So if you go into backplane and you try to select your drive like a new module, and you try to select your Powerflex drive, you're not going to have anything, because you can't add directly to the backplane, at least under the processor that I'm using. So what you need to do is talk through a communications path like an EN2T and ENBT, or communications, actual soft or communications protocol like Ethernet. So at that point, you can go to add new module, because you're talking through that module, right? So we're going to go to add new module, and we're going to type in Powerflex. Powerflex, and then right here you can choose from all your Powerflex drives. So I know that I have a Powerflex 525. Most people would think it would be the E, but that's using a 22 COM E. This is using the embedded Ethernet. So in this case, I'm only using one drive, and I'm using embedded Ethernet. So I'm going to choose the EENET. Okay, I'm going to create. I'll come over here, and as soon as this comes up, I'm going to call this Powerflex 525 example. Give it an IP address. I set my drive up already at 192.168.131. So we'll go 192.168.131. Now the drive currently is a 1-horse drive, so you can put user text down here too if you want to. User text basically is just letting you know what it is. Like if you had a loop number or something like that, you can put it in there. You can also come over here and just upload from device, which is a very cool feature. So what we'll do is we'll upload from device, and I'll show you how that works. Come over here. We don't care about this USB 1203 because I still have that connected. We just care about the drive, so we're going to upload and finish. So that should set all our peripherals. That should set everything. Now, in the key to this, if we want an extra like data input, we could come over here and type in current, like if we wanted to get the current feedback, the last fault, for instance. You could get last fault. Let's see, I think we type in fault, and then you go to down here. Well, yeah, this would be fault code 1, 2, or 3, whatever fault you wanted to use. In this case, let's just use, we'll have fault code 1, and then we'll have output. So we'll have our current output as well. So we'll click OK. Again, all of our parameters should be set for what we uploaded, but we can go over here and synchronize, but we're going to create. So we're going to come over here. At this point, what I highly recommend that you come over here and upload from drive or synchronize. And that's what they call a drive match. And you drive match for the simple reason of having the proper setup in your PLC program and the actual drive itself. And this way you can come over here and turn on automatic device configuration. You can put on automatic device configuration, and that way it will actually, like if you ever had one fail in the future, you can set the IP address and hook it up, and it would automatically download the parameters to the file. Now currently we don't have anything there, but let's go ahead and see if we got our setup done correctly. So let's download to this PLC program. Alright, so we'll come over here, we'll select our path, and notice I'm using factory taught links. You could use RS Links Classic, just really depends on what you want to use. And then we'll click download, and if we have everything set up properly, then we should not get any kind of caution symbols or anything like that. You should have everything talking, and it should be able to see it. And as I say that, you see that apparently I didn't have everything set up properly. So let's see why. This could be the fact of, come over here. The cool thing about this is right here you can see it's trying to validate shutdown. Okay, so what do we have? what do we have wrong here? We'll come over here. Oh, it's just a matter of owning it and configuring it. I think everything is. Yeah, I think everything is done right. Let's just make sure, because the drive is. Let's just put it in run too. And let's see. Yeah, so it is in run. So communication fault, connecting, requested packs for intervals. We do have a loss of communication. Oh, that was because, I know exactly why that was. It was because my drive, when I downloaded to the PLC, it was different than the actual, the way my Kinetics is, Kinetics 6000 is set up. Or not my Kinetics 6000, but my 5400, my switch that I'm using. And what that does is it breaks communications for a little bit. Alright, so we'll come over here, and now we have everything talking, everything is working properly. Let's go ahead and throw some simple commands in here and show you how I would basically program a drive. You come over here, you can do a start, stop. So, and the kick I guess the key to this is you could have your start. You have, we'll just call it a start. And I'm going to have to toggle these bits because again I don't have anything tied to them. You can have this as stop. And then what we're going to do is alias this one. We're going to say Powerflex. And then we'll say Powerflex 525 start. And then we want to alias this down to the actual bit. And then we're going to go down to our outputs for this because we want to start it. And that's going to alias that start. Do the same thing for the stop. Now, one of the key things I like to do here, and a lot of people don't really understand or know about that, is I like to come over here and make sure that I don't have any faults. So I'm going to add in some logic down here. I'm going to do this pretty quick. So I'm going to say Powerflex. We'll call that Powerflex 525 faulted. And then we'll come over here, grab the alias from that, and we'll see if the drive is faulted. Okay, and I'll change the name of this too because I realized I didn't put flex on it. Alright, so that's the start. This is going to be a fault, so if it does fault, I'm going to automatically stop it. And if it, so I want to make sure that it is not faulted before I run it. I also want to make sure that the drive is ready, so we'll say Powerflex 525 ready. And then I want to come over here and drag this down here and make sure that I get the ready bit. Okay, why did that not make? Okay, so let's remake that tag. And Powerflex 525, and this will be ready. Click alias, come over here, alias that to ready, create the tag, so the drive is ready. I'm not going to throw my ready down here because it will conflict some things, and you'll see why in just a second. And then we're going to come over here and also use the active bit. So we're going to say Powerflex 525 active. And the active bit lets you know that it's running. Some people use the running bit, some people use the active bit. It's really up to you. I personally like to use the active bit because it's saying that the drive itself, Powerflex 525, is send out a small bit of torque, and it sensed the torque that it sent out from the motor, so effectively it knows it's running. When this being said, I usually put that in there and it acts as a one-shot. So come in here, being that we separated everything, put a separation in there, make the tags all look the same, and that way a lot of people don't take this level of detail in their programming, and I highly recommend it because you really get a discipline behind it, and things look better, they feel better, they operate better. Let's delete that. I didn't realize I already had that. So Powerflex 525, and this will be stop. You can put stop command if you want to, or whatever you want to name it. This is going to be an output we're going to do, and this is going to basically start and stop it. So we have our starts and stops in there. We can actually come over here and say, okay, well, we don't want to stop it unless it's active. But personally, I like to let it be stopped any given time. It's the safest way. Now we're going to do some math, and we're going to actually multiply, and we're going to get our speed signals. So in our speed, what we're going to do is we're going to say selected Powerflex 525 speed. Sorry about not typing properly, but that's not an important side of programming. Then you want a multiplier. You want to multiply by 100 because the simple fact of Powerflex 525 does actually have a different, well, everything's multiplied on that feature. So you'll see what I'm talking about in just a second. So what happens is, so we'll do Powerflex 525 speed command. Here we go. We'll get it right eventually. And then we come over here and put the speed. That will be another output we do. We're going to use reference this time, frequency command. Okay. And that'll be our speed. Now, what I personally like to do is I like to add logic in here. And I'll show you why. So what I'll do is I'll throw in this drive active bit to say it's active. I want to use the speed that I want to use. So in this case, let's just say 60 hertz. In this case too, if it's not running, then I want to move, let's just move a speed of 0 into my drive command. So if it's not running, do that. If it is running, do that. And we can come in here and monitor our current too. But let's just look at how this situation works right now. So we're currently running, or we're currently at the point where we can run this drive. So let's actually toggle this and start it. You see the drive is running. It's running at 60 hertz. So you can see drive is running at 60 hertz, and it is running the motor. Now the active current, you can come over here if we wanted to and do like a NOP. Or let's drop this and let's get a bit, and I'll do an NOP, and I'll do an AFI, and then I'll do a move, and then I'll create a bit. Well, or you can just pull up the input. So what is the active current? Let's see, active current. Didn't look like it pulled in my current or the output current. Let's see, let's look at output frequency. Interesting, it didn't pull my current in. So let's look at that one more time of why I thought we put that in our definition. Oh, but we overrode it. So we're not actually pulling in our data here, which we could download later because we uploaded from this. So keep that in mind too. So now if I hit, here's the two things behind this. So if the drive faults out for any reason, let's just say I hit a e-stop. Drive faulted, it stopped. I sent a 0 speed command to the drive, and it also latched in a fault, or latched in a stop. Okay, now I can reset this because I have a push button reset, make the drive not faulted again and ready. So then I can actually start it again, but just toggling the bit. And it's a one shot because as soon as the active bit comes in, it actually only does that one time. Again, so as the active bit is running, it sends a signal to the actual drive to say how fast do you want it to run. If I want it to run 45 hertz, I can just change that and it slows the drive down. If I want it to run 10 hertz, you can see that slows that down drastically. Again, so that's just some simple programming to understand, the basic things you would want to know. Before you start it, you want to obviously make sure it's not faulted. You want to make sure it's ready. You really, I guess one could argue that you don't need to have the fault in there in the actual start logic, because if the drive is not ready, it's faulted, right? So if it's faulted, it's obviously not ready. So you could have that argument and say, well, yeah, all right, if that is the case. But personally, I like to see all my bits. I like to see what is giving. The more information that you give yourself while you're programming, the easier it is for you to troubleshoot, and the less mental capacity you have to have when you're actually going through it. Therefore, you can think better as you're troubleshooting. So again, a lot of people might not get that. And if I hit the start button, again, with it not reset, it won't work. When I reset it using the push button, because I have a push button reset, I can hit the start button, it does start, and then if I hit the stop button, it does stop. So you see that. So that's just some simple logic, simple way to set things up, and basically a simple way to do a Powerflex 525. Setting it up and getting the parameters, understanding the protocol of what you should monitor, what you should look at. Every time a fault happens, you should definitely do a stop. Every time you try to issue a start, you should make sure it's not active and it's ready, right? If the drive's not ready, you definitely don't want to try to start it, because it's not going to do anything. And if you send it a start command, a false start command, and then you do reset it, like say for instance, I didn't have this bit here and I sent it a start command and it was not ready, and then I reset it, it's not going to start until you undo the start command and then start it again. So that's why I put this like this, right? So it's very simple, it corrects itself, it's reliable. This is a very simple way to do this. Again, you can challenge yourself and do it many different ways. You can monitor a lot of things. You can have different peripherals in here. Let's just go in here, add the current in here like we talked about doing before. You can come up here. You can't do this while you're online, but you can do this while you're offline. You can add in the output current, the last fault. Let's just not do the last fault. Let's do the current. Yes, this will change. I understand that it will change. And then we'll download. So what I'm going to do is just basically pull out, I'm pulling out my current that I'm using, right? So if you want to understand your current, your power, anything like that, you just add that to your tags that you want to see down on that bottom section. Just make sure you note that it will actually make you download to the processor. And you see again, as it's coming in, configuring, it's just getting, the drive itself has to actually, basically it faults out every time you download. So you can write in code to clear a fault. That's another thing too. If you don't have a push button reset, you come over here and you add in a rung, and then we'll call this HMI reset. We can do an HMI reset and then come over here and then put drive reset. So we'll put Powerflex 525 reset. And then this bit we're going to alias, and we're going to go down to our output, and this is going to be clear fault. Okay, so we can do that as well. And what we can do to clear all faults, because The drive is ready. Everything is good. Now to get everything, also too, you can put a first scan bit in there and automatically reset everything. But let's fault it out real quick. It's faulted right now. You'll see that. And then let's use this reset bit. Just as simple. So you can have a reset, you can have an HMI reset and a push button reset. So if I hit the button again, pull it out, it's faulted, hit the push button reset, it resets. So I can have two different resets. So just keep that in mind as well. So I know this was another long video, but again, very detailed to explain to you, some simple controls you can put in for your Powerflex drive that are reliable and they do work. So just keep that in mind. Hopefully that was helpful, and we'll see you guys on the next one.